Have a look at this. The ice, I can pick it up. It doesn't fall apart. Get some water on my finger. You can see this little drip on the end of my finger. It's holding together. It's not falling apart. Interesting. Okay, so if matter can hold together when you lift it up, well, this doesn't do that, does it? If I lift one, the rest don't come with it. So that must mean that between the particles of matter, there is some kind of attractive force. You know, there's something that's sticking them together so that when you lift one, lots come with it. Have a look at this. Okay, so when we heat a substance, it changes state. Interesting. What if the particles, when you heat them up, they vibrate more? And maybe at some point, those vibrations get big enough that they're able to break free of some of their bonds, and it becomes a liquid, break free of some of those forces. What if maybe they vibrate enough that they can break free completely and become a gas? I took a few tea candles and I put them in this jar and I heated it up. It started melting. You can see the liquid wax up here, and you can see the solid wax that's still solid sitting on the bottom. It's on the bottom because it's more dense than the liquid wax that it's in. We're talking about how particles vibrate a little bit, and the more heat you give them, the more they vibrate. So let's look at that in the different states of matter. In a solid, they're only vibrating a tiny bit, and they're all packed really tight together, so that's very dense. In a liquid, they're vibrating more, and some of those bonds are broken, so they're moving past each other, and it's less dense. There's more space between the particles. And in a gas, it's even less dense because they're all bouncing around and there's no attraction between them at all, really, and they're just all over the place. Lots of space in between them, very low density.